Hello learners, welcome to this particular session. The topic which I am going to talk today is type of sampling, error and control. We have seen that in our preceding sessions we have talked a lot about sampling, we have talked a lot about non-random sampling, probability sampling or non-probability sampling, but in this particular session, which is part of our course called Research Methodology in Statistical Analysis, we have seen that how this sampling error is going to play a very important role, and this sampling error is a routine matter, is a very important ingredient if you talk about population, if you talk about sample, or the extracting the information from this particular population. So sample is quite important, and when we are going to collect the sample, when we are going to take a small bite from a big cake, I think somewhere you get a very good impression and sometimes you get a very bad experience. So this types of sampling error is nothing but talks about how you are going to come out, how you are going to find out the error, and how this sampling errors need to be controlled. Because what we have seen that when you take a sample, when you take a sample from a big circle, some of the information, some of the things need to be left, and these left things sometimes create an error. So anyway, prior to going into the depth of this topic, as far as the sampling error is concerned, as far as the statistical error is concerned, it starts with the collection error. So how you are going to collect the data? If you are going to collect the wrong data, you are going to land up at the wrong results. So there is a very famous quotations which we usually talk in computers, that is how this garbage in garbage out philosophy is going to turn out. So the garbage in garbage out talks about how much you are cautious about your data, that how the data is going to be collected. If you are going to collect a wrong data, you are going to leads to a wrong input, and so wrong results will come as a wrong input taken. So that is the thing, and how you are going to cater the respondents, that is also matters a lot. In this particular image, you have seen that we have to cater the female members, but we have cater the male members. So end of the day, since you have catered the wrong group of the respondents, so you get a wrong result. So this is what all about the research. And when you are going to talk about the research need not to be individualistic in nature. It has to be taken care in such a manner that it have a very holistic approach, it have a very holistic view. So the beauty of researcher is not to do the research, but to try to gather or cater the particular class and creed, and try to collect the information from the respondents in a very systematic manner. So so the respondents verdict is very important, and if you are going to take the respondents verdict in a positive manner, I think you lead to a very good conclusion. So anyway, this is part of our course called Research Methodology in Statistical Analysis. We have covered somewhere around 10 to 12 lectures in this particular subjects, in this particular course, and the first block we are concentrating on, that is research and data collection, and which the very first unit we have already talked about, that is business research, introduction to research, and then research plan, collection of data is there, how you are going to collect the data, either in a primary data mode or in a secondary data mode. Then the sampling comes into picture, and this sampling talks about the sample size, the census, the population, how you are going to do the random sampling, how the methods of sampling is going to be done, that is probability sampling, non-probability sampling, and then finally we are here to talk about the statistical errors or sampling errors. So this error is not a very serious issue, but it's a routine matter. If you are talking about the sampling, I think errors need to be come up in a routine manner, and this routine issues need to be tackled in a very systematic manner, and they need to be done at every juncture. So it's not like that you can start the research or do the sample, and then the error comes, you can shut down yourself. So you have to change the policy, you have to change the strategy, you have to change the plan, and how you are going to reach to the conclusion. So curtain result to research, which we have already covered in our preceding sessions, and research thoughts, which usually comes in our mind when you are a grassroots researcher, and there are certain FAQs which need to be answered, and this is quite important, because frequently asked questions can work as a building block and build your foundation. So there are certain unidentified impressions which is coming in your mind, and this can be resolved only when you when you are going exactly into the depth of the frequently asked question. Then research methods are there. There are certain methods which are very important, like interview method, case study methods, and various methods. These methods are very helpful because by which you are able to float your primary data or respondents, interact with the respondents and collect the information from there. Then research plan and research problem is there. When we were talking about the research plan, we see that this research plan is very important, very important ingredient, because this research plan talks about that how you are going to formulate your research at every juncture. It's not like that you have a research, you have planned to do the research for 4 years or 5 years, but so the plan need to be changed. There are certain time when we observe that the plan is going to be changed with the change of time. So there must be a random sampling. And this formulation of objective is there. Then hypothesis, we have already talked about the null hypothesis, the accepted hypothesis, or rejected or alternate hypothesis. So research design is something which is very important thing. It's not like that you have to design the research in the preliminary stage. You have to do the designing at every intervals, after certain time, after 3 years, 4 years, or after 1 year, when you are going the process of collecting the data, at that time you have to do that. And sampling is very important ingredient, because in research you are not in a position to cater the whole population or reach to the whole universe. The good point is that it can only come up when you are going to apply the sampling, because sampling collects the sample and takes the sample from some of the domains and try to create an impression on the basis of that data collection method. So this is very important, because when your circle is quite bigger, you are not in a position to reach to the particular domain. Then what exactly you do? You just go through the sampling format or methodology, or the techniques which are applicable, which can provide you a way to get the data or extract the information from the respondents, and then try to build the gap with the help of that. So random sampling, non-random sampling, we have already talked about. So anyway, this particular chapter is very important chapter, because it starts with the sample population sensors which we have already covered. Then why sampling, then essentials of good sample, methods of sampling which you have already done a session. Then sample size, what could be a sample size? There must be some rocket science behind that your sample size could be 300, 400 or 500. So sometimes what happens, we make a sample size, and then after certain time we observe that there are no reciprocations from the respondent ends. So in that case you have to enhance your sample size. So and when you are going to enhance the sample size based on the sampling errors which had been observed, I think there is a great role of sampling and non-sampling errors, because this talks about how the errors can be rectified and how you are going to control the errors. So that is more important. So anyway, now we will talk about why does sampling error occurs. Here is the problem. The problem is that different sample drawn from the same population can have different properties. That is very true. And when we see that that when we are going to collect the sample from one of the zones, I think if you see this particular image, you will find out the whole grey circle is the population, and you have got some 3 or 4 small white circles. The first, the small sample circle talks about the collection of sample from one of the areas, whereas other S is talking about the collection of sample from other areas. So now when you have draw the sample, when you have reached to the conclusion of that, I think the different impression comes, the different approach comes. So now when you are going to accumulate all those data, you get a very diversified version of it. So what I mean to say, that could be the reason, whatever the result used to come, it's have a very holistic view. So taking a population, only have a subset of the population, and now we have seen that how this what are the causes of sampling errors. The volunteer sampling and convenience sampling, and causes and bias are there. How do you reduce? So use randomness in choosing your sample, that is there. And sampling errors talks about the population, and then in the population you have got a sampling frame. If you see, the outer circle talks about the population, which is quite bigger in nature, and whole the ingredients are part of the population. Either it could be the sampling frame or sampling or response or the whatever the error used to come. And so Then the moment you get the population, now you redefine your sampling frame, and this sampling frame is somewhat inner part of the population, and then in that sampling frame which work as a jurisdiction, you have to confine yourself as far as the collection of the data is concerned, as far as the collection of the sample is concerned. So after deciding the sampling frame, we have seen that we have made the sample, and these samples are then converted into sent to the respondents, and respondents used to reciprocate. So what we have observed that there is a response, coming from the inner circle, and then response error is coming. Then in this response error, what we have observed that when respondents not reciprocates or left certain information, these are considered to be the response error, and chance error is also there. It's not like that the only response error is there, the chance error is there. You have not reached to the particular respondents. So when you have not reached to the particular respondents, you are not in a position to get an opportunity to know his view or opinion. So this is also considered as an error, because if he or she has given the his verdict, I think if you record it, you get a different mindset. So frame error is there. Now frame error is also there because that there is a gap between the population and sample frame, and frame error says that maybe some of the sample frame you have taken, maybe if you go to the other frame, I think some other information which need to be done. So this is the biggest challenge which is coming up in population, that or in sample, that population is a bigger circle and sample is a very small circle. And when you cater the information, when you take the information from that sample, I think the thing is there. And sampling error is more talking about errors of representation, and target population who you want to ask, like to whom you are going to send the sample, and their possibility of the coverage error. And when you are moving from target population to sample frame, that is from bigger circle to the smaller circle which you have confined or designed, I think the list you use as a sample from, and again there is chances of sampling error. So first error is considered to be the coverage error, because you have not designed the frame in such a manner that you are going to cover or cater the entire population. So there is a flaw of coverage error. Then the sampling frame, when you are moving towards the sampling frame, from sampling frame to sample, I think the sampling error comes. So this is a very important difference between the coverage error and sampling error, because coverage error comes when when you have a population and you design your sample frame, and when the sampling error comes when you have a sample frame and you are taking a sample from there. So now from sample to respondents, I think when we send it to the respondents, some of the respondents reciprocates and some never answers. So these are considered to be the non-response errors. So in the table also we have, in the particular figure we have also seen that how this non-response error is going to be done with the help of that. So anyway, let's throw a light on what exactly the error is as a whole, as a general purpose. The error is a biasness. It can be mistake, it can be inaccuracies, or it can be all the things are synonymous. It's not like that. Sometimes when we go for non-random sampling or when we do the research, there also we have observed that we follow convenient sampling or judgmental sampling, or the snowball sampling. So this is quite biased in nature, because you are quite rigid, or you just confine yourself to the particular domain. So there also the model is there, and sometimes we are not biased, but the mistake need to be committed. So again, that is considered to be error, and because that mistake can come up when you are not able to frame your sample frame in such a manner. So error is defined as a discrepancy between the observed value, sample statistic / value delivered from the sample survey. And there are certain key takeaways which need to be taken care when you are going to talking about the sampling error. Sampling error is a statistical error that is well defined, and it because when we are in the process of doing applying the statistics or the inferential statistics, I think the error used to come up, and that occurs when analyst does not select a sample that represent the entire population of data. So what we observed that the results found in the sample do not represent the results that would be obtained from the entire population. Sampling error can be reduced by randomizing sample selections or increase the number of observations. That is very true. Sometimes what we have observed that we have taken a sample of 300 or 400, or which we consider as sample size, but only 100 used to reciprocates, and remaining 300 become stagnant or not able to respond. So in that case, you have no choice but to go for additional sample, collection of additional sample, which can be done only when you are going to enhance your sample size. So you will extract the information from different domains and try to get the results of that. So it's like that, when you have taken Delhi as a base as far as consumer behavior is concerned, and you have bifurcated into north, south, east, west, and then you realize that that you are not getting that much data, then you can bifurcate the South Delhi into southeast, southwest, or northeast, northwest. This kind of modus operandi need to be created. So it can, and when you are going to enhance the size, I think the biggest challenge come up is about the cost and time. So non-sampling errors, if you talk about, it's selection bias, question effects, survey formats effects, interviewer effects. Whereas when you talk about the sampling error, it's non-response bias, transfer of findings, self-selection bias, behavioral considerations. So what we have observed that there is a difference between sample results and true population results, if you talk about. And when you're talking about sampling errors, this occurs when data are incorrectly collected. For example, if you collected a sample and then the problem occurs. So anyway, source of non-sampling error is non-sampling error broadly grouped in 3 numbers, that is group A, group B and group C. And group A we have already talked about, its non-response errors, whereas group B talks about errors resulting in the stage of data collection or taking observations. Like when we have started taking the and when we have floated the questionnaires and it reached to the respondents, and what we observed that that respondents are facing certain issues which are somewhat confidential in nature, or not able to answer some of the questions, or not able to fill the answer in totality. I think there are certain response errors which need to be done, and there are certain errors resulting from data processing, tabulation errors. So now what we observe that non-response errors arises due to various causes, that is not at home, refusal or lost schedule. These are considered to be non-response error because the refusal used to become. So the question need to be framed or designed such a manner that there should not be this kind of lost schedule or refusal should be there. So when you are going to talk about survey A, low response rate, and when you are going to talk about survey B, is high response rate. So survey A talks about all users which are invited to do the survey, and survey B talks about invited to do the survey. So we have seen that in both the things users are more or less same, but as far as the survey invitation is concerned, it is 7% and it is 30%. So survey A and survey B are compared, and the same number of users are taking as far as the survey is concerned, but survey B had a higher response rate because it sent fewer survey invitations. So survey B is less subject to non-response error. That is very true because you have sent it to n number of people, and the non-response rate is very, very high as compared to that. So end of the day, what happened? There is a chances that you get non-response errors. So you don't have to worry about it, but the results are more trustworthy. That is very true because since you have catered as far as the all user circle is concerned, the invited to do the survey is bigger than that, but so that is the thing. So making trustworthy, having the same sample size as survey. So what I mean to say that type 1 and type 2 errors are one of the important ingredients which is very important, because in statistical hypothesis testing, a type 1 error is the rejection of true null hypothesis and also known as false positive findings or conclusion. And on the other hand, we have seen that type 2 error is somewhat different, and it talks about non-rejection of false null hypothesis. So in our preceding session, we have seen that how this null hypothesis, or the accepted hypothesis, or the rejected hypothesis, or alternate hypothesis are taking care. Null hypotheses are come up when you formulate the objectives, and on the basis of these objectives you have 4 or 5 the hypotheses which are considered to be the null hypothesis, and from this null hypothesis we just for the safer side, we have 5 alternate hypotheses. So if null hypothesis is rejected, the alternate hypothesis is accepted, or vice versa. If alternate hypothesis is accepted, the null rejected. So what we have seen that null hypothesis is true, and reject null hypothesis, type 1 error is there. If null hypothesis is true and we are able to fail the reject null hypothesis, then correct outcome is there, so true negative is there. So on the other hand, we have seen that if we are going to measure reality and measurement, I think if both are true, we are getting correct information, or if reality is true or measurement is false, I think type 2 error is there. If reality is false, measurement is false, measurement is true, we are getting type 1 error, which is false positive. So type 1 and type 2 errors are very important, and one has to be quite cautious. So type 1 error is the rejection of true null hypothesis, which has to be taken in the very beginning. So when we formulate the objectives and when we take a null hypothesis, and if that true null hypothesis is rejected, I think, and so this is considered to be the false positive finding. So in some of the cases we observe that we take null hypothesis and we assume that when the researcher reciprocates or the respondent reciprocates, it is going to reciprocate the particular thing. So anyway, null and alternate hypothesis is perform the test, and if you see null hypothesis, when we perform the test outcome accept, and alternate hypothesis, test outcome rejected. Then true pass, true fail is there, and this is called the type 2 error not detectable, whereas type 1 error is detectable. So anyway, I think errors are very important thing, and we have to take the things in a positive sense, and blessings in disguise is there. If errors are coming maybe in the mid of the research, I think we have to enhance the sample size or divert ourselves as far as the collection of the sample is concerned. So sampling error, random error, the level of its control by sample size, a larger sample size lead to a smaller sample error. So non-sampling error, systematic error, and this kind of thing is there. So when you are going to how we are going to avoid the sampling errors? So we have to be less bias, and lack of precision is there, and non-reproducibility is there. So if there could be a lack of consistency, if there could be lack of precision or lack of accuracy, I think the error is going to be there, and so that is the reason there must not be a less bias approach. Like when we are using a non-random sampling or the non-probability sampling, I think we are quite biased because we are using a convenient sampling. So in that case, the best part is that you should have a different mode of collection of sample, because if you are biased or do the thing as per your convenience, you get a very stereotyped results. To eliminate ourselves, to eliminate from this model, I think we have to be quite think. So there are certain way by which you are going to reduce the sample error. One way to reduce sampling error is to increase the size of a sample. This is a basic thing which is very important, that if you want to reduce the sampling error, you have to increase the size. But if you are going to increase the size of sample, I think some more inverse correlated relationship come, because if your sample size grows, there would be sampling error decreases because you are getting a very holistic view. But on the other hand, the cost is very high, or the sample size is going to be a time consuming affair. So you will face another kind of issue. So when you are going to talk about two measures that affect the accurateness of margin of error, and margin of error tells you how many percentage points your results will differ and from real population value. And this margin of error is a very methodical way of calculating the errors, and if you see, it is based or usually prepared only one of three different levels of confidence, that is 99%, 95% and 90%. But the optimum way is 95% level. The 99% level is the most conservative, while the 90% level is the less conservative. So the 95% level is the most commonly used phenomena, which is going to, because this confidence level is going to be evaluated at the 95% level, and 95% confidence interval with a 4% margin of error means that your statistics will be within 4 percentage points of real population value, that is 95% of the time. So if the level of confidence is 95%, the true percentage for the entire population would be within the margin of error around the pole. So margin of error is going to work as a alarm bell, and if you are in the margin of error, I think up to some extent you have achieved the task. It's not like that you will get a 100% level. So this margin of level is 95%. I think you have reached to the conclusion, and up to some extent your whatever the data you have gathered on the basis of population or on the basis through the sample, it's somewhat optimum in nature. So when you are going to talk about the confidence interval is a range of values used to estimate the true value of the population parameter. And we have seen that in this particular image, that population is not confined to, or the sample is not confined to particular jurisdiction, but taking from all the domains of population. So when you are going to take the sample from in a holistic manner from various domains, I think you have a very good view, you have a very good way by which you are going to do that. And standard error is a routine matter, and these standard deviation of sampling distributions and margin of error is 95%. We have seen in this case. The best way of explaining this is how margin of error works. And we have seen that if we take a average of mean of the sample, it is coming the mid of the rectangular box. But if you take the sample mean, it is little bit deviate from there. So what we have observed that in this the population mean is true value, sample mean is survey result, and we have seen that the 95% probability is coming up, and so margin of error is 95%, which is here. So it means that if you are near to the margin of error, I think you can reach to the conclusion. So that is very good model by which the things are going to be there. And now there are certain FAQs which are very important when you are going to talk about the statistical error or sampling error. So when you are going to talk about the statistical error, is the confidence interval the same as the margin of error? The margin of error is how far from the estimate we think the true value might be. In either direction, the confidence interval, that is plus minus margin of error, is there. So either it could be somewhat added or somewhat subtracted, but there is a variation of 4 to 5%. So 95%, if you are getting this interval, I think confidence interval, I think you can reach to the conclusion. So why does the margin of error increases as confidence increases? The margin of error increases as the level of confidence increases, because if you want to be more confident than the interval contains, the population mean that we need to make the interval wider. So number states that as the sample size increases, the sample mean approaches the value in the population mean. So now what we observe that there are certain way of calculating the sampling errors, which could be through the formula. The sampling error formula is x bar minus mu, and this is the difference between the sample statistics and the value of the corresponding population parameter, assuming that the sample is random and non-sampling error has been made. So there are formula for non-sampling errors, and this means that standard deviation of sampling of x bar are called the mean and standard deviation of x bar, and are denoted by mu or sigma. So now what we have observed, that when we are going to for calculating sampling error, it is very inherent in nature that sampling process, due to the fact that samples are only subset of total population. This is very true, and it's really cumbersome for the the researchers to go into the depth of the population and collect the data from all the aspect, or rather deeply go into the universe and collect the data, because this is really time consuming. And if you are talking wholly about the population, I think the purpose of the statistics is not going to be solved, because the beauty of the statistics is that with the help of sample you can reach to the conclusion, or not able to reach to the conclusion, but up to some extent you can interpret that what exactly the model is. So sampling error is quite good if you consider it in a positive sense, because sampling error is somewhat gives you a alarm bell, or make you aware about that by this way the error is coming up, or the respondents are not reciprocating, there is a non-response error, or your sample frame is not good, or some issue is there, you can just rectify yourself. So when you're talking about the sampling error, it's quite good, and one has to cross verify in every juncture. So after certain time, when you have collected the data and the response sheet had been developed, I think prior to the response sheet, we have to work and check in a pilot mode, in a pilot project mode, that whatever the information which we have gathered or collected, I think whether this is going in a foolproof manner or in a right direction. If you are not going to do, if you're not getting the data, or interpret the things in a right manner, I think you can reframe yourself, or you can resize your sample for a framework. So this is the way by which the things are going to be changed, and sampling error is very important ingredient, because its work is a blessing in disguise. So if you think that that error is coming up, or the results are not you are not getting a result, and the results are coming in an outlier mode, so in that case you have to apply certain statistical tools, or you don't have to emphasize more on the descriptive statistics, but to follow the inferential statistics, because inferential statistics talks about the certain test or statistical analysis by which you can reach to the conclusion. And sampling, we have already seen that in the random sampling or in the non-random sampling, that both have got a utility and both are going to be useful when you are going to apply. So random sampling works when you want a result which could be probability in nature, probabilistic in nature, or you want unbiased results, whereas when you are quite biased, you want to be quite favorable in nature, you do a convenient sampling, or the judgmental sampling, or snowball sampling. So in snowball sampling, we have observed that the biggest challenge is that the respondents not reciprocating, or you have not got the huge bank of respondents. So in that case, to whom you have sent the sample, you ask them to give the links, you ask them to give the reference, and with the help of this reference, you can go to other reference. So one people can give a reference of 3, 3 can give a reference of 6, and 6 can give a reference of other people. So by this way, what you are going to do, you are making a figure of a bank of respondents, and then you are going to collect the information. So what I mean to say, this sampling error is quite inherent in nature. It is very important ingredient. So being a researcher, it is a moral duty that how we are going to take a sample. So I think by this way we can accomplish our research, and in our coming session we can talk more about that. Thank you very much.